Good day everyone, here's our math challenge for today. And here's our question. Use hexadecimal number system to represent this binary number. If you want to try this problem, just pause this video. We have 20 seconds and timer starts now. Time's up. Now let's answer this question together. First thing to do is, what is a base number? A base number is the number of digits or combination of digits that a system of counting uses to represent numbers. A base can be whole number greater than 1. The most commonly used number system is the decimal system, commonly known as base 10. Its popularity as a system of counting is most likely due to the fact that we have 10 fingers. In general, a system with base b that is greater than 1, a string of digits d sub 1, d sub 2, d sub 3 up to d sub n denotes the number d sub 1 times b raised to n minus 1 plus d sub 2 times b raised to n minus 2 plus all the way up to d sub 0 times b raised to 0, wherein d sub I is greater than or equal to 0 but less than b. Now for example, this number is read as 143 base 8, meaning this number is in base 8. And in decimal, we can represent this number as follows. We have 3, the last digit, multiplied by 8 raised to 0. For the second digit, multiplied by 8 raised to 1. The third digit, we have 1 multiplied by 8 raised to 2. Now, if we simplify this, 1 times 8 squared plus 4 times 8 plus 3 times 8 raised to 0, we get 99. This 99 now is in base 10. So, 143 in base 8 is equal to 99 in base 10. Now, another question is, how can we convert 99 in base 10 into base 8, going back to 143? Now, we have a simple trick to do that. So first, let's take the 99, then divide by 8. If you do that, 99 divided by 8 equals 12, remainder 3. Now, let's take this 12, then divide it by 8. 12 divided by 8 equals 1, remainder 4. Now, let's take the 1, then divide it by 8. 1 divided by 8 equals 0, remainder 1. Now, at this point, we stop because the answer now is 0. Because 0 divided by 8, we get still 0 and remainder 0. Alright? So now, the question is, what is 99 in base 10 converted into base 8? And the answer is, we have 1, 4, 3. From the bottom number, going up. So we have 1, 4, 3, base 8. Therefore, 99 in base 10 is equivalent to 1, 4, 3 in base 8. Alright? So now, let's take our given number. So we have 11110, 1110, 1101. This is in base 2. Now the question is, how can we rewrite this number into base 10 or in decimal? Let's start with the rightmost digit. So this 1 is just 1 times 2 raised to 0. This 0 is just 0 times 2 raised to 1. The next one is just 1 times 2 raised to 2, and so on and so forth. Now, we can disregard this 0 because 0 times any number is just 0. So, this simplifies as 2 raised to 0, because this is 1. 1 times 2 raised to 0 is just 2 raised to 0. And we have 0 times 2 raised to 1, or just 0. So, we cannot have 2 raised to 1 here. And we have 1 times 2 raised to 2 will give us 2 raised to 2. Therefore, this number right here can be written as follows. 2 raised to 12 plus 2 raised to 11 plus 2 raised to 10 plus 2 raised to 9 plus 2 raised to 7 plus 2 raised to 6 plus 2 raised to 5 plus 2 cubed plus 2 squared plus 2 raised to 0. Now, as you can see, we don't have 2 raised to 1. We don't have also 2 raised to the 4th power. Also, we don't have 2 raised to 8 because those are just 0. Now, let's simplify this result. We have 2 raised to 12. 2 raised to 12 is just 4,096. 2 raised to 11 is just 2,048. 2 raised to 10 is just 1,024. 2 raised to 9 is just 512, and so on and so forth. Now, what will happen if we add those numbers? We get 7,917. Now, this number is in base 10. Now, the question is, how can we convert this number into hexadecimal? Now, take note that hexadecimal is in base 16. Hexadecimal means 16. So, what we're going to do is to get 7,917, then divide by 16. If we do that, we get 7,917 divided by 16, we get 494, remainder 13. Now, take this 494, then divide by 16. We get 30, remainder 14. Now, get this 30 divided by 16, and we get 1, remainder 14. Now, get this 1, divide by 16, and we get 0, remainder 1. Now, at this point, take note that in base 16, we have 15 numbers. So, namely, we have 0 to 15. But, in base 16, we use letters. So, from 0 to 9, we use the same thing, 0 to 9. But in 10, we use A. 11, we use B. 12, we use C. 13, we use D. 14, we use E. And 15, we use F. Therefore, this one is just 1. This 14 is E. Another 14, we have E. And this 13 is D. Therefore, 7,917 in base 10 is equivalent to 1 EED in base 16. And we are done. So this binary number is equivalent to 1 EED in base 16. But there's another solution to this question. Now let's go back to this part, wherein we represent this binary number into its decimal form with a powers of 2. Now, take note that 16 is just 2 raised to the 4th power. So, what we're going to do here is to consider 2 raised to multiples of 4. So, namely, we have 2 raised to 4, raised to 8, raised to 12, and so on and so forth. So, let's separate this 2 raised to 12. Now, from 2 raised to 11, 2 raised to 10, 2 raised to 9, let's factor out 2 raised to 8. If we do that, we get 2 raised to 8 multiplied by 2 raised to 3 plus 2 squared plus 2 raised to 1. Now, from 2 raised to 7, 2 raised to 6, and 2 raised to 5, let's factor out 2 raised to the 4th. If we do that, we get 2 cubed, 2 squared, and 2 raised to 1. And this is multiplied by 2 raised to the 4th power. And now, let's simplify. 2 cubed plus 2 squared plus 2 raised to 1 will give us 14. This is just 14. 2 cubed plus 2 squared plus 2 raised to 0 is just 13. Now, 2 raised to 12 can be written as 2 raised to the 4th power raised to 3. Now, this 2 raised to 8 can be written as 2 raised to the 4th power raised to 2. And take note, 2 raised to the 4th power is just 16. Now, let's rewrite this number a little bit. Now, at this point, clearly, this binary number can be written as 1 times 16 cubed plus 14 times 16 squared plus 14 times 16 plus 13. Now, we can rewrite this number as 1. This 14 is, we know we have E. This 14, another E, and this 13 is D. Therefore, in base 16, this number must be equal to 1 EED, and we are done.